last time we built 3 AI opponents so that we can have someone to play against with. Now, over the past few days, I've been working on implementing the game rules. And in order to explain my code, I need to first explain how to play the game. So let's get started. In order to win the game, you have to have a hand of 14 tiles. So right now, as you can see, I have 4, 8, 12, 13, 14. So this is a hand that can potentially win the game, right? But usually you have to play a tile. So you can only have 13 tiles on your hand when you're waiting. When it is your turn, you will get another tile. And that's the only time when you can have 14 tiles, right? So that's like the only time when you can win. Now, the win condition for this game is basically you have 4 sets of 3 and then 1 set of 2. So usually you want to group your tiles into groups, right? So here I can group these 3 into one group, these 3 into one group, these 3 into one group, and then these 3, and then these 2. So you want to have n times 3 plus 1 times 2. Now, each group of 3 can be either a sequence or a triple. A triple will be 3 tiles of the same kind. So here I have 2 character 4s, and here I have 2 bamboo 7s. If I get another one, they can become a group, right? And then that group can contribute to the winning hand. Now, each group of 3 can also be a sequence, which is given here, right? This is 2, this is 3, this is 4. So 3 numbers can form a sequence if they're next to each other. Those are the requirements for groups. And then for the pair, it's just a pair. They have to be the same. So let me show you what a winning hand might look like. This is what a winning hand might look like, where you have 3 2s, and then 2, 3, 4, and then 1, 2, 3, 4, 5, 6, and then 8, 8. This is the most basic kind of winning hand. Okay. Now let's talk about some more complicating winning hands. So here we have this one, which is worth more points, but it's harder to get, right? You have triple 1, triple 2, triple dot 1, triple dot 2, and then 3, 3. In this case, you have 4 triples plus a pair. This is considered like a triple, I don't know, like a quadruple win hand, right? Where you only have triples and a pair. This is worth more than the one before, where you have both triples and sequences. Now, there are also other different types of winning hands. For example, this one, where in each group, you have either a 1 or a 9. So this one is triple 1, triple 9, triple 1 for bamboo. This icon is bamboo 1. And then this group has 7, 8, 9, which has a 9. And then in the pair, it's a pair of 9. So each group has 1 or 9. And that makes it this combination, which is times 4 the point. This is times 2, this is times 1. And then you have this one, which is roughly translates to like a pure category. So you only have one category in your hand, and it has to satisfy this combination. So like 3, 3, 3, or 1, 2, 3, right? A sequence or a triple plus a pair, and it has to be all of the same category. And then there are also special types. This is like a special case of winning hand, and this is very hard to get, but it's an exception where you just have 7 pairs. It's also considered a winning hand. So 7 times 2, which means it's still 14 cards, right? And then there are a lot more winning hands, and they just get more complicated and harder to get. Also more points. The most basic one is just this one, where you just have n times number of sequences, m times number of triples plus 1 pair, where and then m plus m equals 4. All right. So what I've been working on is implementing the win condition loop. So I have a class that checks if a player's hand is a hand that belongs to one of these combinations. And I'm just going to go through the logic I used. I want to say this is probably not the most efficient way to do this. I can think of using some sort of depth first search or some sort of algorithm that might do this more efficiently. But for the sake of Mahjong, it's actually not that bad because you always have at most like, I don't know, like 18 cards or something. So even if your algorithm is not super efficient, you're not going to get like more than 20 cards. So at one time, you're only going to check like 20 cards. It doesn't have to be designed to scale, right? So let me just go through this class, which checks the player status. So in the player class, I've added this attribute called status, where it's a set of player status, and these are all of the statuses that the player can have. So the player can be waiting, playing, and then all of these different statuses, right? And one of them says who, which means win. So if a player has this status, it means that their current hand, which is bind to the player class hand tiles, right? Their current hand is a hand that can win. So let's go back to the player checker and see how I implement it. So basically, in the constructor, I give it a player object and I give it a tile. This tile corresponds to the new tile. Usually player only has 13 tiles on their hand, and then one more which they take, right? It's a new tile. And this class is supposed to check if this new tile plus the existing 13 tiles or more forms a winning hand. And it checks all of the combinations. So how I did this was I basically take the player's current hand and then take the new tile and I just put them together in the tiles. So a list of tiles. And then over here, I put them into categories. So this line basically separates each category. It basically separates the list of tiles into categories. So in this map, you're going to have bamboo mapped to say like 1, 2, 3, and then character mapped to 4, 5, 6, 7, 8, 9, 9, 9, or something like that. And the reason why I do this is so that I can generate the sets for each of the category, and this saves some computing, or it's more efficient because in none of the winning hands it requires a combination across categories. So in each group, like a triple or a sequence, it has to be the same category, even if you have cross-category winning hand, right? So in this case, I have two different categories in the winning hand, but in each group, there's only one category. So it's easier if I just categorize the tiles from the start. Then I call this generate sets function, which basically goes through the entire list and then finds all of the combinations. So it's like a sliding window. So I take the first three and then I slide to the next one. So I take position 1, 2, 3, and then 2, 3, 4. Or in this case, I take 1, 2, 3, and then I take 1, 2, 4, and then I take 1, 2, 5, and then so on until this reach the end, and then I take 1, 3, 1, 3, 4, and then 1, 3, 5, and so on. And for each of those groups, I use this function called set groups, which sets the group into one of these buckets I set up here. So it can be a pair, a sequence, a triple. These two, I will talk about it in the next video. But for now, just know that there are pairs, sequences, and triples. And then this function just puts the group into the corresponding bucket. Where is it? Here. So if it is the same, I create a new group object, and then I put it into pairs with an attribute called pair. If it is a triple, triple, sequence, sequence. Once I have this list set up, so I have the player's hand and the new tile broken down into pairs, sequence, and triples, I then start to form like a combination. So it's important to note that these three sets contain all of the possibilities, right? It contains all of the possibilities of pairs, sequences, and triples that can be formed from player's hand plus player's tile. With this combinations, I then take the player's hand and see if any of the combinations up there can fit into the player's hand. And I do that by creating like a duplicate of the player's hand. And then for each of the groups up here, I subtract the tiles in the group from the player's hand and see if the player's hand is empty in the end. Here is the function, can who from hand. Who just means win. So I create a copy, and then for each group in groups to list, if hand copy removes tile, right? If I can't remove the tile anymore, that means that this potential hand is not going to match the player's hand. And I just return false immediately. And in the end, if the hand copy is empty, that means I've done it. That's the combination. Yes. It's also important to note that this class only checks if you can who. It doesn't tell the player which combination there is, right? And it's intuitive because you only get one tile, so it has to be that combination, right? I don't have to output the combination. Let's talk about how I go from these three sets to the combinations. And it's through this class called fitter, who fitter. So I give it all of the pairs, sequences, and triples into the fitter. And here it generates all of the combinations for the existing groups stored in the set. By the way, I'm using a set so that I can avoid duplicates. So here we can see that there are all of these different rules. So I can use the fit standard rule, which transforms all of the sets into all potential hands that fits the standard rule template. Here I have 7 pairs rule, which fits the sets again into all of the winning hands that satisfy the 7 pairs rule. And then I return these sets of list of groups to the player status checker. And then it runs can who from hand with that group. So here, as you can see, I use who fitter fit all who, which takes all the who's who rules and then outputs all of the sets. And these are the potential candidates. And then for each group in candidates, I check if that one can move from hand. It seems like a lot of combination calculation, but when testing, I was testing this algorithm with, I believe, like 10,000 random tiles, and then it returned the result in like 3 seconds. So it compares all of the different combinations for 10,000 hands, and then outputs all of the who results, which is pretty fast. And for the sake of this game, it's just going to check if the player has a hand when someone else plays a tile. So it's not going to check like every 1 millisecond. So it doesn't need to be that fast. So I'm pretty happy with where this is going. I'm currently not doing very well in terms of implementing the pawn and con game rules, which is a little bit tricky, and I will upload a video when I figured it out. But this is what I'm currently working on, and this one is working. So yeah. Thank you so much for watching, and I'll see you in the next one.